So we're now going to have a look at an example of binomial expansion and how we apply that principle in context of an exam style question. The first thing we're going to look at then is this one that's saying, basically using the format above where we know that this binomial expansion a plus b cubed has to be equal to the following, find the binomial expansion of these. So all we're going to do in this case is just say, well, clearly in our first instance, a is going to be equal to 2x and b will be equal to 3. So all we're going to do is sub that into the form we know it must make. So we're going to get a cubed, which is 2x cubed, plus 3 lots of 2x all squared times b to the power of 1, plus 3 times a to the power of 1, now times b squared because this is going up. The power is increasing for b, and finally we just end up with b cubed. Then just expanding these out, so it's going to be 8x cubed. This will be 3 times 4x squared, so 3 times 4 is 12. Then we're going to get 12 times 3, so we're going to get 36x squared. This one will be 9 times 3, which is 27, times by 2, which is 54. And then finally we're going to get 3 cubed, which is 27. And there's our answer. So a little bit quicker than maybe doing the long expansion by hand. So this one was part A. Let's have a very quick look at part B. Only difference with part B is you just need to be aware of that negative. So again, you just say, let's let A equal x and B equal negative 5. And we apply it in the same way. So it's going to be, if we go back to this general form, we can see it's always a cubed. Well, that's a bit dark. So we have, this is our general form that we are using. So it's going to be x cubed, because that's my a value, plus 3 lots of a squared, which is x squared, times negative 5, plus 3 lots of a times my b squared value, plus b cubed. So just be aware of those negatives. We're going to get x cubed plus 3 times negative 5 will actually make negative 15x squared. 3 times negative 5 squared, so that's going to be positive 75x, and negative 5 cubed is negative 125. And that is the answer to that one. Okay, final thing then, we have been asked to use the 5th row of Pascal's triangle. So let's just zoom over here where we did Pascal's triangle a moment ago. We can see that 5th row is 1, 5, 10, 10, 5, 1. So what we can do is then apply this principle of using the 5th row. So let's write that out up here. So we have the 5th row is 1, 5, 10, 10, 5, 1. And you can see these, it is symmetrical through the middle with these. Now, thinking about that pattern that we have whereby the powers go up for b and they descend for a, we can then say, well, this first term, so this will be the coefficient, 1, but this will start with, because we're looking at the 5th row, a will start with a power of 5 and b will have a power of 0, so it'll just be 1. This next one, a will now start going down and b will start coming up. So this will be a to the 3, b squared, a to the 2, b to the 3, a to 1, b to the 4, and finally it will just be b to the 5 because a will be to the power of 0. Now a handy little tip with these is, because we are looking at 5th row, the powers on each term actually always add back up to 5. So 4 add 1 would make 5, 3 add 2 makes 5, 2 and 3, 1 and 4, and 5. So you know you're kind of on track if they're adding back up to the power that is on the binomial expansion. So we're now going to use this then to expand this. So let's start writing this out. We have a equals 2x and b is equal to negative 2 on x. Using this, we are going to start with the coefficients, remember, are these numbers above. So it is always adding as well. When we do this, we just sub in the negatives. So we're going to get x to the 5 as my first term, plus 5 lots of a to the 4, which would be this, times b, plus 10 lots of a cubed times b squared plus 10 lots of a squared times b cubed, well, that should be an x, plus 5 lots of a to the power of 1, so it's just an x on its own, times b to the power of 4, and then finally plus 5b to the power of 5, which is negative 2 on x to the power of 5. And then from here we just simplify. So x to the 5 is just x to the 5. And then have 5 times negative 2, so that's going to be negative 10. I then have an x to the 4 divided by an x, so that would be x cubed. I then have 10 times negative 2 squared, which would be positive 4, so I'll get 40. And then we have an x cubed divided by an x squared, so that's going to leave me with an x. I then have negative 2 cubed, which is negative 8, times 10, so that's negative 80. And I have an x squared divided by an x cubed, so I'm actually going to get an x as a denominator here, because it'll be x to the power of negative 1. I then have negative 2 to the power of 4, so that is positive 16. 16 times 5 is actually 80 as well. And in this term we also have an x divided by an x to the 4, so that will leave me with x cubed as a denominator. And then finally I have negative 2 to the power of 5, which is negative 32 divided by x to the 5. And that is my final term. So the binomial expansion is x to the 5 minus 10x cubed plus 40x. Take 80 on x plus 80 on x cubed, take 32 on x to the power of 5. And they're your first two examples.